Thank you so much. Good evening, everyone, and welcome to this talk. To begin with, I'm really happy to be invited. I would like to extend a warm thank you to Professor Osama for introducing me to Lisa. And another thank you actually for Professor Hadi. I have always been following his work, but I was not lucky enough to listen to one of his talks. And today, this tick mark checked already. So yeah, thank you so much once again. Before I get started, just would like to say that I'm not a statistician. I'm not sure if this is good or bad news, but I work in decision theory. So I'm a decision theorist, you can say. I'm also working with data science. So I flip-flop between those two areas, data science and decision science, and about which I will talk today to you. Yeah, so this is a quick outline to what I will be talking about today in the next half an hour or less, maybe. Decision making, like I said, this is my area of expertise and area of research, and also I've been doing consultancy, as Tonia explained already. So I'm close to both worlds here, the research world and the consultancy world, I would say. Then I explain about the classical decision theory, contemporary as well. Yeah, the junction here, the trajectory points between statistics and decision making and AI and decision making, and then some of the challenges that we encounter while conducting research on that area. And finally, how I see, and many others as well, the future of decision making. Yeah, so when we say decision making, what do we mean? It's basically that we have set of alternatives and then we aim to achieve a certain goal. And then the purpose is to choose or select one of those alternatives to maybe maximize a gain or minimize a loss or so. So this is basically selection of alternatives. It might seem straightforward, but it's far from being so. So for, you can say, centuries or even ages, humans, us, have monopolized decision making. And bad news is this is no longer the case. We're not anymore the sole decision maker on planet Earth. Machines and AI models and robots are also doing the same. So a lot of people now are fishing into the same ocean, if we may say. So we have been doing decision making as humans, but then with the introduction and the exponential increase in AI, then AI models also are sometimes doing that on their own without us humans in the loop, like I will explain shortly in the future slides. Decision making has been studied by different scholars, and they come from different backgrounds, like in particular behavioral economics, and then statistics, psychology, political science, and philosophy as well. And this interest in the number of decisions that we humans make on daily basis has come to the interest of different researchers and different research institutions. I don't know why, but that's the case. So a lot of people have been interested in like counting or following up on how many decisions do we make on daily basis. Some estimated it like 220 something, as you can see on the slide. Others even have gone really bold and said we humans make approximately 30,000 decisions. So this includes your decision to join that session and to join the network and then to listen or to ask or to dress or to take a route to work or to home, etc., etc. So if you count with that granularity, with that level of granularity in mind, then that's a lot of decisions. But in my opinion, I think it's really hard to quantify the number of decisions that we make. What is we have consensus upon is like we humans make a lot of decisions on daily basis. How many? That's a different story. What I wish to say here is like, yeah, we lack the consensus on that number. Yeah, how do we study the decision theory? So we have a so-called classical decision theory. And classical decision theories actually identified three elements relevant to making decisions, and those are the decision itself. So let's say that you make a decision about resource allocation. There is a government, and then that they wanted to allocate resources related to education or health to the different geographies, for example, in a country. Yeah, hiring, firing. So this is about the decision itself. And then you have the person. As I said, it is no longer solely human here or a person making the decision. It could be agent or an AI model here. And then you also have the decision-making process. So this is like the procedure that you follow to make decisions. Together, those three have been studied heavily in the literature of decision theory, and then they have actually been there for a while. And when it comes to how decision theories approach those three elements towards understanding how we make decisions, we have had that polarization, if you will, in decision theory. And then we have some theories assume that humans, like I said, remember in the past, we used to be the only one making decisions on the planet, but not any longer the case. So that we humans are rational beings. So we make rational decisions. We always try to optimize our gains or minimize losses and have this economic and rational thinking in mind. So this is called normative decision theory, or how decisions should be made. On the other hand, on the other extreme here, then you have also the descriptive decision theory. On the descriptive here, we aim to have like a good enough. Yeah. So this is like a good enough. It's far from optimization, or optimization here is out of reach. So we have to be happy with those kind of like good enough or satisfying choices that we make. So this is about how decisions are actually made. Yeah, so this used to be the case until recently we started to see more contemporary theories in decision making. Again, let's put some highlights onto the three elements of decision making. Like I said, those three elements are the decision maker, the process, and the decision itself. When it comes to the decision maker, so it used to be a person, still sometimes, yes, it is still the case, or a group of decision makers. Of course, if it is individual, that is like clear. When it is a group, then you have to study and investigate where they are located, what kind of management, rules or procedures governing this, and look at the power, etc., etc. So an individual or a group making the decision. Good decisions are decision makers, are rare to find. Yes, according to studies, a good decision maker is some thing that is not easy to attain. Also, research is indicating there is a relationship between the qualities of the decision making that exist in organization and their welfare. You have good decision makers, you have good business, you have good business results. So that is the understanding. And then there is also a relationship between organizational welfare and societal welfare. And you can actually infer this kind of indirect relationship between also decision-making skills and societal welfare. So a good and quality decision making and decision maker actually is something rare, but it's something that is very good to have. And not having those qualities, do influence, as we trace that in the literature, both organizations and societies. But here we come to hear about the rationality, the cognitive limits that we humans have. Yeah, and this is the starting of what is coming ahead of us shortly. So that we humans have bounded rationality, yeah? So bounded rationality here, where we have optimization is out of reach, right? But then unlike that, we have also unbounded rationality assumptions that it is the opposite, of course, but it means that we know everything, we can compute everything, and we can remember everything when it comes to decision making. Yeah, perhaps that's not a human, actually. So because we have cognitive limits, yeah, we are sometimes biased when it comes to the decision making, or we cannot analyze all the data that we have So that Professor Hadi spoke about and presented solutions to some of its problems. Even if you have those analysis techniques, sometimes it's really difficult for us humans to comprehend. Okay, so what do we do then? We will come to this. So we spoke about one of the three elements of classical decision theories. And then second is the process. We follow a process, and this also has been extensively studied in the literature. And you also have the seminal work of Herbert Simon on the phases of making decision, which include collecting the data, design of alternatives, and then the choice. And then next, then added two more phases that we need to implement. If you have a very good quality decision, but it was not implemented, then we have not solved the problem. And then it's also important that we monitor the implementation. So this is one of the examples of the decision-making processes. But this area of research actually, like I said, has attracted also the attention of too many researchers. But at the end of the day, we're doing more or less those phases. So some researchers maybe added a bit more or cut down into less number of phases. But at the end of the day, we have to collect the data, think about alternatives, and then choose one. Yeah. But when we work with decision making in the decision making process, actually we operate in an environment that we do not fully control, right? And that environment could be certainty, yeah, very lucky if it is so, but it's not the case in too many decision situations. Or it could be uncertainty, or in between, where we have risks attained. So like I said, certainty is like rare, very good to have, but rare to find. But then most of the time we operate under risky conditions, I would say. Yeah, so that therefore we need the statistics, and therefore this is one of the strong associations between statistics and decision making. We operate in making decision under risk and uncertainty quite a lot. And therefore, we need actually to analyze the data, quantify risks, and also make informed decisions. We need to use models to spot patterns and trends and correlations. And then we also need to have evidence. We don't want to make the decision in a discretionary manner from the top of like the decision maker mind. So we wanted to have consistency as well. And for all those reasons, we need to use statistics, and it's very difficult without in making decisions. Yeah, and like I said, now the world has changed, and then three pillars of decision theory have also emerged into being five. And then those five are, as you can see here. So we talked about the decision itself, like again, resource allocation, hiring, firing, etc. The decision maker, a person or a bot or an individual or a group, and then the process, like I explained, Herbert Simon's process. But quite recently now we have two more elements to the decision theory landscape, and those are data and then analytics. But one might wonder, sometimes actually we have a counter argument in the literature says, yeah, we have always had data for centuries as well. And we have had analytics as well. But when we speak about data here, we speak about big data. And that phenomena is new. We live in the era of big data. So it's not really the same data. It's not the same problems that we encounter. It's not also the same benefits and the same potentials that we are able to extract here. So therefore, data is a new element into the decision-making scene, and also analytics. So we have actually machine learning and we have deep learning models that also opened the new eyes and opened also new potentials. They also brought about new challenges, like I will explain some of them shortly. But that's now how contemporary decision theory look like. So 5 elements compared to what it used to be 3. And then a key element here is analytical models. So we use models and then we apply models on top of big data. So yeah, and one of the notions here that was put is like, since we humans have cognitive limits, remember we have bounded rationality. So then we have human bias as well. We get tired, we need to sleep, we need to eat, etc. And then if you are making a decision amid all of that, yeah, so the quality is certainly influenced by. So we need to use models because models do not get tired, they don't need to eat, they don't go to sleep, etc. So the idea was like, yeah, we wanted to get rid of those cognitive limits and the bias, the human bias. So this was the assumption. So we're ready to solve the problem. Have we solved the problem or not? And this is what I try to approach in the next few minutes, actually. So we also realized after using models, AI models in decision making, that also models have limitations. It's not the same limitations that we humans have, but it's a different set of limitations. Maybe if you go by the number, if we like count the number of limitations or errors that we have had when humans solely made decisions, yeah, maybe we had more. But we also brought about new types of decisions. I will give a couple of examples for the sake of time. So models are time consuming to build and test, and then they have a lot of assumptions, and then they are complex that we human decision maker cannot digest. Although this very problem has also a solution, which is leaving the models to make the decision on their own. Yeah, with all the goods and bads associated with that phenomena, that is, as we speak, currently happening worldwide. So assumptions associated with models sometimes oversimplify reality as well. Yeah, like I said, the number of errors probably, if we go by the number, has been reduced, but then there is a shared area here that both models and humans have made errors, but then we also have realized that there are very specific errors that models do make. I only focus on two of them. So here, researchers at Google Brain spotted this problem in a deep learning model. So this is actually a very sophisticated model. It's not like a simple model or so. So here the model is mixing up US school bus, as you can see, which is very clear in color, even with an ostrich. And in another also research, the model was like, this is very dangerous, actually mix up a stop sign with a speed limit sign. So here we are actually, I'm referring here to problems that AI models can make, but it's hardly for humans to make. Of course, if we assume someone on top of what we are doing, then it's difficult for humans to make such a kind of mistakes. So back to the question I asked a few minutes ago, we thought that this will solve the problem. It partially solved it, but it created new types of problems and errors. Yeah, this also has introduced the so-called decision-making styles, and those styles are all actually active as we speak at a different capacity. And here I don't distinguish even between organizations and governmental agencies as well. So the four different styles, so-called decision styles that I will speak about in the next minutes or so, are all still alive and in use. And one of which is the classical approach to decision making here is like we have human judgment that is influencing decisions. So you can here feel like, yeah, we are still in control. In some businesses and in some organizations, that is correct. But remember the bounded rationality. Remember the human cognitive bias. So this has goods and bads. The good side is like, yes, we are still in control. But the bad side is like, yeah, remember the human bias. Remember the bounded rationality. Remember that we cannot comprehend and analyze big data. Yeah, that Professor Hadi spoke about in the previous session. So here, this is one of which. And the second one is like, yeah, here we started to recognize actually big data, but we're not recognizing it in full. We're not using really sophisticated models or deep learning models or so, but we're only summarizing the data. So this is like we are only scratching the surface of analytics here and of models. So summary data and then human judgment and decisions. We are still in control. That is still happening. And then this has been triggering the so-called triple DM or data-driven decision making. So here we can make decisions based on evidence that come from data. Okay, and then here came, yeah, something that was expected, yeah, and then this is like AI models are only making the decisions here And here, the human is not in the process. So we analyze big data using models, and then we make decisions. So this has also been termed decision-making 3.0, but actually more frequently, the human outside the loop set up to decision-making. So what is good with this one is, yes, now we don't have this cognitive limit that humans do have. We don't have the cognitive bias as well. So this is too analytical. I can analyze millions and billions of data sets towards making a decision. So this is all good. But then there are things that we cannot actually take into account. How do you quantify pain and love and loss and fear and those kind of concepts? That's very difficult to quantify and to take into account when you make decisions with humans outside the loop. So this has also goods and bads associated with it. Yeah, yeah. And then we're now actually are witnessing a fourth style in making decisions, and this is called decision making 4.0. So here we try to get actually the benefits of both worlds. So this is the world of human decision making still is brought back to the scene, but also the world of big data and AI models. So here we analyze data not only in summary like what we used to do with decision making 2.0 style, but here we use like massive analytics, and then we summarize the possible actions. Yeah. And then we use human judgment to get also influenced by own experience and non-digital sources. And then in the end, we reach a decision. This also has been termed human in the loop. So we have seen human of the loop and human in the loop. Yeah. So like I said, research is showing that the four styles in making decisions are actually still in use. But here, when you think about how we make decisions, sometimes even in a single organization or a government agency, I will make an example shortly about government agencies, especially that I work and live in Sweden, that Swedish government is actually supporting those algorithmic decisions, sometimes called, or data-driven decision making. We need governance to this, because we now have three different possibilities when it comes to the role of humans. That we are in the loop, it means that we are in control, influencing what data to have and to analyze, what kind of models to use, and what kind of problems to use models in association with to solve. Yeah, but sometimes we are on the loop, so we're not really fully in control. So it's too little that we can do to influence the process. And also we have thirdly, human of the loop. As you can see on the figure to the right, that there is no human in the loop. And this is like the so-called also the human of the loop, or decision making 3.0. And this has worked for some type of decisions, but it's also not working for some other types of decisions. So regardless of which one we follow in a certain organization or a government agency, we need to govern this. Which decisions do we want to delegate completely to the machine versus that we wanted to keep as humans, or that we wanted to collaborate? And if we collaborate, how such a collaboration would occur? Because also collaboration is also witnessing some difficulties in practice. Then when it comes to a certain organization or an agency that wanted to tap into those benefits of data-driven, this triple DM for data-driven decision making, can we evaluate readiness? Because also research showing that without assessing readiness, I mean, failures is evident, and failure statistically has been actually identified, because many businesses assume like we're ready for AI in decision making, but research is showing otherwise evidence that many businesses were not ready, and they started and then they stopped because they realized that one of or more of those five elements to decision theory are not ready. So we have worked at Lulea University and collaborated with also other researchers in Finland and developed this framework to assess readiness and identify areas for improvement before an organization start implementing data-driven decision making. That otherwise, if you don't assess and take actions, possibility for failure or cancellation of the total project is higher. And now with AI, what do we mean? What do I mean in particular when I say AI in this session? So I refer to this is the technology and systems that aim to mimic our intelligence. And then specifically, they are able to perform cognitive functions such as learning, problem solving, and the focus of this talk, which is decision making. And then you have the evolution of AI, the narrow AI, and then the general AI, and the super AI. So ANI, AGI, and ASI. And then the predictions is like we will be outperformed. Actually, in some areas, this has already occurred. But at large predictions, this could happen more and more. This is in next year, in 2 years or so, in 3 years at max. Another also research is showing that the number of businesses adopting AI, at least in one function, is on exponential increase, actually. In the last 5 years, this grew from 20% of companies into 65%. That means AI is already in use at many organizations. Yeah, this does not solely mean in decision making, but it is in use for different possibilities. And actually, one of the recent developments in AI is called agentic AI. I'm not sure if many of us are familiar with the term or not, but at least for the sake of understanding, it's like these are like complex AI systems. So that this is where you could be using probably multiple AI systems, multiple LLMs, and then you also have non-LLM, maybe classical machine learning, analytical tool, another system, and then they all work together to solve a complex problem. And while they do so, they have autonomy to learn and to make decisions. Yeah, they make decisions. This is what I highlighted here on a different color. So there's not only these systems are designed to make decisions, but part of which is making decisions and actually making multiple decisions in a sequence. So they have a goal to achieve. They can interact with one another actually to fit the purpose, and then creating the so-called agentic AI systems. So here we have another perspective for the use of AI in decision making in a more complex manner. A recent study took many by shock, especially if you are a big fan of AI. It was conducted at MIT. And then this study was explaining the huge amounts of money invested in generative AI, in particular, one branch of AI. And then use of ChatGPT Copilot was witnessed actually in businesses. And then success is defined as deployment after an organization is piloting a certain AI tool. And then they also have set up for measuring return on investment, ROI, for 6 months post-pilot. What was really striking or shocking to many is like 95% of those businesses are achieving zero return on their investment in Gen AI. And that also means 5% only are making it to like financial tangible results. While 80% of organizations explored AI tools, 40% reported deployment, and that means like 50% of those businesses actually. And then only 5% are making tangible results. Yeah, so 90% of employees use AI tools, but 40% of the companies have official subscriptions, which means that many employees are using it like we call it shadow system. So it's not really sourced formally by the company, but employees are individually subscribing to those tools. 60% evaluated tools, but 20% reached to pilot, 5% to production. While we have a feeling and we keep hearing that, especially from AI companies, etc., and supporters, that AI is everywhere and it is like making progress and success in every single corner. From time to time, we see studies like this telling us otherwise evidence here. When AI was introduced to decision making, like I said, the belief was like, yes, we're bringing the solution to the problem. What was the problem? Again, it was like cognitive bias that we humans have when we make decisions. And also we have bounded rationality. We can't comprehend everything. We can't like be consistent in making decisions. Yeah. But then when AI was introduced, actually, that brought different set of problems as well. So we have the algorithmic aversion, and then each one of those actually is studied by different academic institutions worldwide as we speak. So algorithmic aversion is like, yeah, as from the name here, some humans try to averse making decisions based on algorithmic evidence. Explainability is difficult. So sometimes you get an output of a sophisticated algorithm that is very difficult for us humans to comprehend and to understand. So we don't know why certain features are here or there, or we have missed some, and the process that the model has actually followed to reach that conclusion, etc. And that's hard to explain. Therefore, also research is conducted to make those models more explainable than they are. Accountability. What if we have a decision that was like mistakenly taken by a model? Whom is now held accountable? Is it the company that sold maybe this AI solution? Is it the researcher that developed the model? Is it the tester that tested the model? Is it the company or organization or a government agency that actually have been complacent in utilizing the model without actually testing or making sure that it would not make such type of mistakes? So accountability sometimes is not clear. Who is accountable when an error happens? In agreement resolution. So this has been witnessed in different organizations applying AI in decision making, in particular in justice systems, in courts. Actually, some US courts allow models to be used, and actually some many courts actually worldwide, and in healthcare organizations as well. What happens if you have the AI models recommending or going in a certain recommendation or direction, but then others, human expert, judge, or medical staff is going on the other direction? So how do we resolve that tie? The social challenge, so people are losing jobs, and that actually is traced and reported. And the TMI paradox is like too much information. It's difficult to sometimes know and to tell how much information do I need to support this decision. Too little information is not good, but too much information also is not good either. Yeah, one of the cases here that, like I said, is associated with the Swedish government, because in Sweden, they have changed the law of government agencies to allow them to make automated decisions. And after that, many agencies, including the so-called in Swedish Arbetsförmedling or the employment service, started to do so, but then it has resulted in like 70,000 people were prevented from getting the social solidarity schemes. And people lost their jobs, and then, but this did not stop other municipalities and agencies in Sweden from still utilizing AI algorithms in making decisions. But here you can think about and evaluate this, like the pain that was caused to those 70,000 people until they got their schemes back. How do I quantify this? This is very difficult. Also, the social cost, because many people, thousands of people, have lost their jobs that used to be officers on deciding on those schemes. So this is just one example of how far we can go. And then probably pre-final slide is like, how do I mix a human with machine together towards making decisions? Sometimes it's clear, like this example, which you find in many papers studying this blend of humans and machines together. So when machine work in solo, then they beat humans, as I put here on this example. IBM Blue versus Gary Kasparov. And then when Gary Kasparov wanted to reproduce this as a combo rather than solo, then human and AI pairs, they bested human. This makes sense. But they also outperformed machines, solo machines. And this triggered the idea like, yes, I mean, we have different types of intelligence, humans and machines, that if we are able to have the right recipe, the right governance, and the right controls, we can actually cultivate much better than each one separately. And this actually is the last slide I would like to say, which is about hybrid intelligence. I mean, if you are in that area of interest of like AI and the decision making, then this is like a term that is now we see quite often. Funds and also papers and research centers are now focused. In a nutshell, we wanted to cultivate both benefits and then govern and then regulate how this could happen. And this has created that new term, hybrid intelligence. In its basic definition, this is where humans and machines collaborate together. Like I said, this is far from like mature or far from complete, but this is the direction that we have as we speak for research into that area. That is all from my side. Thank you for listening. And again, thank you for inviting me.